Computer Science Standard 12. The chapter is Algorithmic Strategies, right? In this topic we will see one by one. Here in this topic we will see the next one is Introduction to Algorithmic Strategies. An algorithmic is a finite set of instructions to accomplish a particular task. It is a step-by-step procedure for solving a given problem, right? An algorithm can be implemented in any suitable programming language. Algorithms must have input and output and should satisfy the following characteristics such as here definiteness and then correctness and effectiveness, right? Here data are maintained and manipulated effectively through data structures. Algorithms can be developed to store, manipulate and retrieve data from such data structure. Example for data structures are arrays, structures, list, tuples, dictionary, etc. Right, here examples for data structures are arrays, structures, list, tuples, dictionary. Okay, here this is algorithmic strategy. The way of defining an algorithm is called algorithmic strategy. For example, to calculate factorial for the given value n, then it can be done by defining the function to calculate factorial once for the iteration -1. Then it can be called recursively until the number of required iteration is reached. Okay, in that case algorithms are used here: search, sort, insert, update and delete. To search an item in a data structure using linear and binary search, right? Sort, to sort items using bubble sort, insertion sort, selection sort, etc. Insert, to insert an items in a data structure. Update, to update an existing items in a data structure. Delete, to delete an existing items in a data structure. Okay, these are algorithms are used. But here characteristics of an algorithm. What are the characteristics of an algorithm? Here input, output, fitness and definiteness. Here effectiveness and correctness. First, input is a 0 or more quantities to be supplied. Output, at least one quantity is produced. Finiteness is nothing but here algorithms must terminate after finite number of steps. Here definiteness, all operations should be well defined. For example, operations involving division by 0 or taking square root for negative number are unacceptable. Effectiveness, every instruction must be carried out effectively. Correctness, the algorithms should be error free. Okay, these are the characteristics of an algorithms. Here extra also is there, the characteristics of an algorithms: simplicity and then unambiguous and then feasibility and then portable and then independent. Here simplicity means easy to implement. Unambiguous, we know algorithms should be clear and unambiguous. Each step and their input and output should be clear and must lead to only one meaning. Feasibility should be feasible with the available resources. Portable, an algorithm should be generic, independent of any programming language or an OS, able to handle all range of inputs. Independent, an algorithm should have step-by-step directions which should be independent of any programming code. Okay, here writing an algorithm. Algorithms are generic and not limited to computer alone, right? It can be used in various real-time activities also. Knowingly or unknowingly, we perform many algorithms in our daily life, such as packing books in school bag, finding shortest path to search a place, scheduling day-to-day activities, preparation for examination, and etc. As we know that all programming languages share basic code constructs like conditions and iterations can be used to write an algorithm. A typical algorithm is shown here in this process, input, process and output. Now we will see example for writing an algorithm. How to make coffee, right? So here ingredients needed. What are the needs? Here making coffee: milk, water, coffee powder and sugar, right? These ingredients are the inputs of an algorithms. Preparing a cup of coffee is called process, right? The output of this process is coffee. Okay, here procedure to make coffee. Here to take a bowl with coffee powder and then boil the water and pour it into the bowl. Here filter it, boil milk, mix sugar and filtered coffee along with boiled milk, right? So pour the coffee into cup to serve. So any another correct procedure may be adopted. These kind of procedures can be represented using an algorithm, which is a step-by-step process which helps the programmer to develop the program, right? Here algorithm to find square of given number and display the result. This is second one. Here algorithm to find square of given number and display the result, right? Step 1, start the process. Step 2, get the input x. Step 3, calculate the square by multiplying the input value and then display the result square and then stop. Here algorithm could be designed to get a solution of a given problem. A problem can be solved in many ways among many algorithms. The optimistic one can be taken for implementation. Okay, here algorithm and program is simply called algorithm vs program. Algorithm helps to solve a given problem logically and it can be constructed here with the program. But program is an expression of an algorithm, is a programming language. Algorithm can be categorized based on their implementation methods, design techniques, etc. Program can be implemented by structured or object-oriented programming approach. There is no specific rules for algorithm writing, but some guidance should be followed. Program should be written for the selected language with specific syntax. Algorithm reassembles or resembles a pseudocode which can be implemented in any language, but program is more specific to a programming language. Okay, yes, this is important 3 mark, sometime 2 mark, right? Yes. Next we will see analysis of algorithm. Here the analysis of algorithm: computer resources are limited. Efficiency of an algorithm is defined by the utilization of time and space complexity. Analysis of an algorithm usually deals with the running and execution time of various operations involved. The running time of an operation is calculated as how many programming instructions executed per operation. Analysis of algorithms and performance evaluation can be divided into two different phases. One is a priority estimates. So a priori estimates and then a posteriori testing. Sir, what is these two? This is a theoretical performance analysis of an algorithm. Efficiency of an algorithm is measured by assuming the external forces, right? But posteriori testing, this is called a performance measurement. In this analysis, actual statistics like running time and required for the algorithm executions are collected. Okay, Here, complexity of an algorithm. Suppose A is an algorithm. Here A is an algorithm and N is the size of input data. The time and space used by the algorithm. A are the two main factors which decide the efficiency of A, right? Now will we see first this is a time factor and space factor. Now will we see time factor. Time is measured by counting the number of key operations like comparisons in the sorting algorithm, right? Space is measured by the maximum memory space required by the algorithm. The complexity of an algorithm is f of n gives the running time and or the storage space required by the algorithm in terms of n as the size of input data. Here the time complexity of an algorithm is given by the number of steps taken by the algorithms to complete the process. Space complexity of an algorithm is the amount of memory required to run to its completion. The space required by an algorithm is equal to the sum of the following two components. First one is a fixed part is defined as the total space required to store certain data and variables for an algorithm. For example, simple variables and constant used in an algorithm. A variable part is defined as the total space required by variables which sizes depends on the problem and it is iteration. For example, recursion used to calculate factorial of a given value n. Okay. Next, efficiency of an algorithm. Computer resources are limited that should be utilized efficiently. The efficiency of an algorithm is defined as the number of computational resources used by the algorithm. An algorithm must be analyzed to determine its resource usage. The efficiency of an algorithm can be measured based on the usage of different resources. For maximum efficiency of algorithm, we wish to minimize resource usage. The important resources such as time and space complexity cannot be compared directly. So, time and space complexity could be considered for an algorithmic efficiency. Okay. Now, method for determining efficiency. The efficiency of an algorithm depends on how efficiently it uses time and memory space. The time efficiency of an algorithm is measured by different factors. For example, write a program for defined algorithm, execute it by using any programming language and measure the total time it takes to run. The execution time that you measure in this case would depend on a number of factors. Speed of the machine, compiler and other system software tools, and then operating system, and then programming language used, volume of data required, right? Here, method for determining efficiency. However, to determine how efficiently an algorithm solves a given problem, you would like to determine how the execution time is affected by the nature of the algorithm. Therefore, we need to develop fundamental laws that determine the efficiency of a program in terms of the nature of the underlying algorithm. Okay. And then space time trade-off. A space time or time memory trade-off is a way of solving in less time by using more storage space or by solving a given algorithm in very little space by spending more time. To solve a given programming problem, many different algorithms may be used. Some of these algorithms may be extremely time efficient and others extremely space efficient. And then time space trade-off refers to a situation where you can reduce the use of memory at the cost of slower program execution, or reduce the running time at the cost of increased memory usage. And then sir, asymptotic notations. Okay, here asymptotic notation. So asymptotic notations are languages that use meaningful statement about time and space complexity. Here they mostly used so asymptotic notations to represent time complexity of algorithms. Here, the number one is big O. The big O is often used to describe the worst case of an algorithm. Big here of the symbol, the omega symbol, big omega is the reverse big O. If big O is used to describe upper bound or worst case of asymptotic functions, big omega is used to describe the lower bound best case. Now third one is big here O, inside the here middle is a slash. When an algorithm and complexity with a lower bound equal to upper bound, say that an algorithm has a complexity O n log n, and here also omega n log n, it is actually as the complexity n log n, which means the running time of that algorithm always falls in n log n in the best case and worst case. Okay, here so asymptotic notations: best, worst and average case efficiency. A list of n values stored in an array. If we want to search a particular element, the algorithm searches by comparing the key element with each element in the list among n elements sequentially. The best case would be if the first element in the list matches with the key element. The efficiency in that case could be expressed as 0, 1 because only one comparison is enough. Similarly, the worst case in this scenario would be, if the complete list is searched and the element is found only at the end of the list or is not found in the list. The efficiency of an algorithm in that case would be expressed as ON because n comparisons required. The average case efficiency of an algorithm can be obtained by finding the average number of comparisons as given below. Here minimum number of comparisons 1, maximum number of comparisons equal to n. If the element not found, then maximum number of comparison equal to n. Therefore, the average number of comparison equal to n plus 1, here whole divided by 2. Hence, the average case efficiency will be expressed as O of n. Okay, here algorithm for searching techniques. Algorithm for searching techniques. In the algorithm for searching techniques, first we will see linear search. Okay, here linear search about we will see. Linear search is also called sequential search, is a sequential method for finding a particular value in a list. This method checks the search element with each element in sequence until the desired element is found or the list is exhausted. In the searching algorithm, list need not be ordered. Use linear search in the example 10, 14, 19, 26, 27, 31, 33, 35, 42 and then 44. Your linear search here 33. How sir? Here you see linear search for pseudocode. Pseudocode here first point is they traverse the array using for loop. In every iteration, compare the target search key value with the current value of the list. If the values match, display the current index and value of the array. If the values do not match, move on to the next array element. If no match is found, display the search element not found. To search the number 25 in the array given, linear search will go step by step in a sequential order, starting from the first element in the given array. If the search element is found, that indexes is returned, otherwise the search is continued till the last index of the array. In this example, number 25 is found at the index number 3. How, sir? Here you see the program. Linear search example, index value start from 0, 1, 2, 3, 4. Here value 10, 12, 20, 25, 30. In this example, 25 is found at index number 3. Values equal to 5, 34, 65, 12, 77, 35. But search element is 77. Here the index also 0, 1, 2, 3, 4, 5. Value 5, 34, 65, 12, 77, 35. The output, the fifth element, the index value is 4. The 77 is their index value position is 4. Okay, yes. Here binary search. In this binary search, here binary search, also called off interval search algorithm, it finds the position of a search element within a sorted array. The binary search algorithm can be done as divided and conquer search algorithm and executes in logarithmic time. You see binary search 0 and then 16 is I, middle is 8. Sequential search starting from 0 to 16. Given a value, you see 1, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59. Here also that step 1, 3, 5, 7, 11. So 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59. But in that search binary search, you will see here, sir, what do we find, sir? The binary search pseudocode start with the middle element, right? If the search element is sequential, the middle element of the array, the middle value equal to number of elements in array whole divided by 2, then returns the index of the middle element. If not, then compare the middle element with the search value. If the search element is greater than the number in the middle index, then select the element to the right side of the middle index and go to step 1. If the search element is less than the number in the middle index, then select the elements to the left side of the middle index and start with step 1. When a match is found, display success message with the index of the element. If not match is found for all comparisons, then display unsuccessful message. Here binary search example. Here this last one. List of elements in an array must be sorted for the binary search. Let us assume that the search element is 60 and we need to search the location or index of search element 60 using binary search. The value will be 10 to here 99. So index position also 0 to 9. First we find index middle element of an array, right? Here middle equal to low plus I minus low whole divided by 2. Here middle equal to 4. Here in that case, here it is 0 plus here 9 minus 0 whole divided by 2 equal to 4.5. The fractional part ignored, so the 4 is the mind value of the array. Here compare the value, here the search element with the value stored at mid value location 4. Okay, here location 4. Here that case the value binary search example. Now compare the search element with the value stored the mid value location 4. The value stored at location or index 4 is 50, which is not matched with search element, as the search value 60 is greater than 50. Here now we change our low to mid plus 1 and find the new mid value assigned using formula low to mid 1. Here middle equal to lower plus I minus low divided by 2. Here our new mid is 7. Now we compare the value stored at location 7 with our target value is 31. Okay. Dear children, Now I will discuss about the binary search. Is this example, right? Here the list of elements in an array must be sorted first for binary search. Let us assume that the search element is 60 and we need to search the location or index statement. Here index of search element 60 using binary search. Here the given a value is 10, 20, 30, 40, 50, 60, 70, 80, 99, right? The index value is start from 0 to 9. First, we find index of middle element of the array. Middle equal to low plus I minus low is whole divided by 2. Right? Here middle equal to 4. Here is 0 plus 9 minus 0. Right? Whole divided by 2 is equal to 4.5. This is a fractional part ignored. So 4 is the mid value of the array. Compare the search element with the value stored at middle value location 4. Now binary search, this is example. Now compare the search element with the value stored at mid value location 4. The value stored at location or index 4 is 50, which is not matched with search element as the search value 60 is greater than 50. Now we change our low to middle plus 1 and find the new middle value again using the formula low to middle plus 1. Here middle mid equal to low plus I minus low whole divided by 2. Okay, here our new middle is 7 now, right? Here we compare the value stored at location 7 with our target value 31. Here binary search example, the value stored at location or index 7 is not a match with search element, rather it is more than what we are looking for. So the search element must be in the lower part from the current middle value location. Here the search element still not found, hence we calculated the mid again by using the formula. Here high equal to mid minus 1, here mid equal to low value, low plus high minus low, these two whole divided by 2. Now the mind value is 5, right? Here binary search example. Now we compare the values stored at location 5 with our search element. We found that it is a match. We can conclude that the search element 60 is found at location or index 5. For example, if we take the search element as 95, for this value this binary search algorithm will return unsuccessful result. Okay, here now sorting techniques is a bubble sort. Bubble sort is a simple sorting algorithm. The algorithm starts at the beginning of the list of values stored in an array. It compares each pair of adjacent elements and swaps them if they are in the unsorted order, right? This comparison and paused to be continued until no swaps are needed, which indicates that the list of values stored in an array is sorted. The algorithm is a comparison sort, is named for the way smaller elements bubble to the top of the list. Although the algorithm is simple, it is too slow and less efficient when compared to insertion, sort and other sorting methods. Assume list is an array of n elements. The swap function swaps the values of the given array elements. Now we will see pseudocode. Start with the first element, therefore index equal to 0. Compare the current element with the next element of the array. If the current element is greater than the next element of the array, swap them. If the current element is less than the next or right side of the element, move to the next element. So to step 1 and repeat until end of the index is reached. Okay, here sorting techniques, here bubble sort. Let us consider an array with values 15, 11, 16, 12, 14, 13. Below we have a pictorial representation of how bubble sort will sort the given array, right? The pictorial example is for iteration -1. Similarly, remaining iteration can be done. The final iteration will give the sorted array. Here at the end of the iteration, we will get the sorted value in an array as given below. Okay, here how sir? You see, given value is 15, 11, 16, 12, 14, 13. But 15 is greater than 11. So interchange. So 15 is greater than 16. No swapping. Why? Because condition is false, right? Here again the 16 is greater than 12. So interchange. And then 16 is greater than 40. So interchange. 16 is greater than 13, so interchange. So 11, 15, 12, 14, 13, 16. Here the order wise here also 11, 12, 13, 14, 15, 16. Right? Here now bubble sort. Sir, in this case bubble sort array, the bubble sort value 63051. Right? Here in this array sorting techniques selection sort. The selection sort is a simple sorting algorithm that improves on the performance of bubble sort by making only one exchange for every pass through the list. This algorithm will first find the smallest element in array and swaps it with the element in the first position of an array. Then it will find the second smallest element and swaps that element with the element in the second position, and it will continue until the entire array is stored in respective order. This algorithm repeatedly selects the next smallest element and swaps into the right place for every pass. Now, hence it is called selection sort. Selection sorting techniques, selection sort. Here the pseudocode. The start from the first element, therefore index 0. We search the smallest element in the array and replace it with the element in the first position. Now we move on to the second element position and look for smallest element present in the subarray from starting index to till the last index of subarray. Now replace the second smallest identified in step 2 at the second position in the original array, or also called first position in the subarray. This is repeated until the array is completely sorted. Now, and then sorting techniques selection sort. Let's consider an array with values 13, 16, 11, 18, 14, 15. Below we have pictorial representation of how selection sort will sort the given. Here initial array and at the end first pass, here at the end second pass, at the end third pass, at the end fourth pass, at the end fifth pass. Right, here 11 and then 13, 14, 15, 16, final also 16. Here sorting technique selection sort. In the first pass the smallest element will be 11, so it will be placed at the first position. After that, leaving the first element, next smallest element will be searched from the remaining elements. We will get 1, 3, 13 as the smallest, so it will be then placed at the second position. Then leaving 11 and 13 because they are at the correct position, will search for the next smallest element from the rest of the elements and put it at third position and keep doing this until array is sorted. Okay, finally we will get the sorted array end of the pass as shown above diagram. Now selection sort example. Here the value is 6, 8, 3, 5, 9, 10, 7, 2, 4, 1. Yellow is the smallest number found. Blue is current item. Green is sorted list. Okay, here sorting techniques. Insertion sort is a simple sorting algorithm. It works by taking elements from the list one by one and inserting them in their correct position into a new sorted list. This algorithm builds the final sorted array at the end. This algorithm uses n-1 number of passes to get the final sorted list as per the previous algorithms. Right. Now, sorting techniques, insertion sort. The pseudo for insertion sort, the step 1 is it is the first element, it is already sorted. Step 2, pick next element. Step 3, compare with all elements in the sorted sublist. Step 4, shift all the elements in the sorted sublist that is greater than the value to be sorted. Step 5, also insert the value. Step 6, here repeat until list is sorted. Now sorting techniques, insertion point. Sir, how sir? Here sorting techniques, insertion point. The values are all given. Assume 44 is a sorted list of one item. Inserted 16, inserted 83. Here inserted 07. At the end of the pause, insertion sort algorithm gives inserted 67, here inserted 21, here the sorted output ascending order shown below, inserted 34 and then inserted 45, inserted 10. But at the end of the pause in the insertion sort algorithm gives the sorted output in ascending order as shown below. Right, here insertion sort given a value is 8526931407. This value is given. Right, here dynamic programming is an algorithmic design method that can be used when the solution to a problem can be viewed as the result of a sequence of decisions. Right, dynamic programming is an algorithmic design method that can be used when the solution to a problem can be viewed as the result of a sequence of decisions. Dynamic programming approach is similar to divide and conquer. The given problem is divided into smaller and yet smaller possible sub-problems. Dynamic programming is used whenever problems can be divided into similar sub-problems so that their results can be reused to complete the process. Dynamic programming approaches are used to find the solution in optimized way for every inner sub-problem. Dynamic algorithm will try to check the results of the previously solved sub problems. Okay, and then the solution of overlapped sub problems are combined in order to get the better solutions. Now algorithm strategies. Here steps to do dynamic programming. The given problem will be divided into smaller overlapping sub problems. An optimum solution for the given problem can be achieved by using result of smaller sub problem. The dynamic algorithm use the memoization. Okay, this is called memoization. Here note the memoization or memoization is an optimization technique used primarily to speed up computer program by storing the results of expensive function calls and returning the cached result when the same inputs occur again. Okay, now Fibonacci series is an example. Fibonacci series generates the subsequent number by adding two previous numbers. Fibonacci series starts from the two numbers here minus FIB0 and FIB of 1. Right, the initial value of FIB of 0 and FIB of 1 can be taken as 0 and 1. Fibonacci series satisfies the following conditions. Right, here Fibonacci of n, FIB of n equal to FIB n minus 1 plus FIB n minus 2. Hence Fibonacci series For the n value 8 can took like this. Here FOIB of 8 equal to 0, 1. Here and then 0 plus 1, 1, and then 1 plus 1, 2, and then 1 plus 2, 3, and then 2 plus 3, 5, and then 3 plus 5, 8, and then 5 plus 8, 13. Okay, here Fibonacci iterative algorithm with dynamic programming approach. The following example shows a simple dynamic programming approach for the generation of Fibonacci series. Initialized here f of 0 equal to 0 and then f of 1 equal to 1. Step 1, print the initial value of Fibonacci f of 0 and f of 1. Step 2, calculate the Fibonacci fi. So Fibonacci b equal to f of 0 and then f of 1. Step 3, print the value of fi b. Assign f of 0. Here also the bidirectional, no, you have to opposite of the gives f1 and then f1 equal to f5 is here assigned. Right, here f0 equal to f1 and then f1 equal to fb. Okay, here go to step 2 and repeat until specified number of terms generated. Okay, for example, if we generate Fibonacci series up to 10 digits, the algorithm will be generate the series shown below. Here Fibonacci first value is 0, second value is 1, so 0 plus 1 equal to 1, and then first value now 1. Here f3 equal to f1 plus f2, so minus 1 plus 1 equal to here 0. So 0 plus 1 is 1. Here 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, and 5 plus 8 is 13, 8 plus 13 21, 13 plus 21 34, 21 plus 34 55. Right,